In this video, I'm going to show you how to solve problems involving a system of equations. Now, this first one involves us determining two integers that have the following relationship. First, 14 more than twice the first integer gives the second integer. The second sentence tells us that the second integer increased by 1 is the square of the first integer. All right, so first thing we need to do is we need to write a let statement. So what we're trying to do is we're trying to determine two integers. All right, so we're going to say let x equal the first integer, and then we'll let y equal the second integer. There is a relationship between the two, but because there's two separate sentences, it seems like we need to write two separate equations. So the first one tells us that 14 more than twice the first. Okay, so this part here, 14 more than twice the first, that tells us that we need to go 14 more than, which means that we need to put the 14 at the back, and it's 14 more than twice the first. And then that will give, which means equals, it will give us the second integer, and the second integer is represented by y. So twice the first integer, so it's 2 times x, because that's our first integer, and then 14 more gives us the second integer. The second piece of information says the second integer increased by 1. So if we take the second integer, which is y, and we increase it by 1, and then it says is. So is another way to say equals. It is the square of the first integer. So the first integer is x. So we're going to square that. So what we have now is two equations, and they both have x and y in it. And we can see that the y is already isolated. So I think it's kind of nice to use substitution to find the values. So I'm going to take y equals to this expression here, and I'm going to substitute it into y there. So I have 2x plus 14, which is what y is. I can put that in brackets to emphasize that, plus 1 equals x squared. So we have an equation where everything only has x's and constants. So let's move everything to one side. So we have 0 is equal to x squared minus 2x and then minus 15. So we have a nice quadratic here, and I can see that I can factor, since I can find two numbers that multiply to negative 15 and adds to negative 2. And those two numbers are x minus 5 and then x plus 3. So two numbers that multiply to negative 15 are negative 5 and 3, and when I add them together, I get negative 2. So my two solutions are x equals 5 from this first factor, and then x equals negative 3 from the second factor. All right, now I'm not done because I've only found my x values, so I need to find my y values, or my second integer. So to do that, I'm going to plug 5 into this equation here, which is probably easier than the one with the squared. So I'm going to go 2 times 5 plus 14, and that will give me y. So y is equal to 10 plus 14, so y equals 24. And then when I plug in negative 3, y equals 2 times negative 3 plus 14, so y equals negative 6 plus 14, and that gives me positive 8. So my two numbers, the two numbers are 5 and 24, so that's 1, or they can also be negative 3, and 8. Now, what you might want to do, it's always good to check this, is to take your answers and plug it back in. Now, not just into the equation here that we wrote at the beginning, but actually into the problem, just to make sure that that is actually satisfies the words in the problem. So it says 14 more then twice the first integer. So if I take my first integer, which was 5, and I'm going to twice the first integer, and if I take 14 more than that, I get 2 times 5, which is 10. 10 plus 14 is 24. So I do get the second number. Now we also want to try it in the second sentence as well. So it says the second integer, which was 24, if I increase it by 1, I get the square of the first integer. So that would be 5 squared. And I do get that because 24 plus 1 is 25, and that equals 25. So that does work. So we also need to try it with your other set of numbers. We have negative 3 and 8. So it says 14 more than twice the first integer. So twice negative 3, and then 14 more. That should give us the second integer, which is 8. So I get negative 6 plus 14. And so that is 8 equals 8. So we also need to check it in the second sentence. So as the second integer, which is 8, if I increase it by 1, it equals the square of the first integer. Now remember, when we're squaring the entire number of negative 3. So I'm going to put it in brackets so that I actually get negative 3 times negative 3, which is 9, which equals my left side. And so this is my check. All right, let's take a look at another example. So in this one here, I can see that the equations are given to me. So a Canadian cargo plane drops a crate of emergency supplies to 8 workers on the ground. The crate drops freely at first before a parachute opens to bring the crate gently to the ground. The crate's height, h, which is in meters, above the ground, t seconds after leaving the aircraft, is given by the following 2 equations. So the first one here with the squared, this one represents the height of the crate during free fall. We can see that it's a parabola. The second one is a line, represents the height of the crate with the parachute open. So how long after the crate leaves the aircraft does the parachute open? And let's express our answer to the nearest hundredth of a second. So what's happening is that we have this airplane, and it drops off some cargo. And I'm going to show that as a parabola, since the first one's an upside down parabola with a negative coefficient in the front. So there would be my axis. And then after dropping through free fall, then it opens its parachute, let's say at this point here, and then it drops in a straight line with a slope of negative 4. All right, so how long after the crate leaves the aircraft? So if this is my height, which is in meters, and this is my time, which is in seconds, this is the time right here, which represents the time when the parachute opens. So what we want to do is figure out where this parabola intersects this line, which is at that point. So we have our 2 equations, and we're going to set them equal to each other. It's nice to use substitution since h is isolated in both equations. So I'm going to say that negative 4.9 t squared plus 900 equals negative 4t plus 500. And we can do this because they both equal h, so they must equal each other. Move everything to one side. So we have 0 is equal to positive 4.9 t squared minus 4t. And then move the 900 to the right side, and we get minus 400. Now this one's kind of hard to factor because we do have a decimal. So I'm going to plug it into the quadratic formula. So I have negative b, so I have negative 4. So the negative cancels. Okay, so 4 plus or minus the square root b squared, so negative 4 squared minus 4 times a, which is 4.9, times negative 400. And let's extend my radical since it covers everything inside. draw a fraction line which covers everything, including the 4, and then 2 times 4.9. All right, simplifying everything in the brackets using a calculator, I get 7,856 all over 9.8. And then take out your calculators to calculate the two values. So I'm going to go 4 minus square root of 7,856, which gives me negative 8.64. And then doing my positive one, 4 plus the square root of 7,856. Press equals, and then divide it all by 9.8. I get 9.45. So the negative one doesn't make sense. We're going to reject it. So answers that are rejected, like this, are called extraneous. So this would be called an extraneous root because it doesn't make sense in this problem. So therefore, the parachute opens 9.45 seconds after leaving the aircraft. Okay, so the next question asks us, what height above the ground is the crate when the parachute opens? So we can see that the time that it opens is at 9.45 seconds. So what's the height? Well, if we take a look at our equation, it says that the height is dependent on the time. So we can use either equation. Both of the heights, which should be the same height because it's the same time, depends on t. I'm going to use the equation of the line since it's easier to use. So I have h is equal to negative 4 times 9.45 seconds plus 500. Now make sure that you save this 9.45 into your calculator from before. Don't clear it because now you're going to use it. So now you're going to go negative 4, or you're going to take that number and times it by negative 4 plus the 500, and that will give us 462.19 meters. So the crate is 462.19 meters when the parachute opens. So don't forget to include your units so that we know it's meters instead of feet.